This is a talk about basically modern software design, modern authentication, because previously we've done simple logins like ASP.NET membership provider and things, but modern systems usually rely on external authentication, external logins, social logins, and the landscape is really shifting to using that stuff. And the newest protocol that the industry seems to adopt is OpenID Connect. So my agenda would be to cover all of the basics that we need to actually work with OpenID Connect. I'm going to go a bit into detail so you have an overview of everything that you need to know in order to use it. There's obviously much more going on beneath the scenes. So if you have questions, let's talk about it afterwards. More detailed questions, maybe we can take offline. But I'm always happy to know what you use, what you need. I also have a comparison with a few other formats in there. And I wanted to do a .NET Core 3 demo, which doesn't work. So you're going to see another demo using an Angular single-page application and a ASP.NET Core backend, which should work, but it involves less live coding. So again, why do we want to use modern authentication? So we usually don't write monoliths anymore. We write microservices or dedicated services, API services that need to deal with both user identity but also service identity. And so we don't really want to implement all this authentication stuff ourselves. And we also want to have a very strong security, because we do not want to end up on have been pwned. And we do not want to be breached. So how do these applications look? Because we have a UI, but maybe this is a single-page application, and maybe we want to have some authentication, but maybe we want to use Facebook or LinkedIn, or maybe even single sign-on with our company. And then we talked a bunch of microservices, and really want to maintain the user identity across all these services. So what's all this identity, authentication, authorization? So interesting metaphor is to think about entering a bar. Like when you want to go into a bar, especially in America, there's going to be a bouncer who decides on who gets in, who doesn't get in. And what an identity really is, when you go to the bouncer and say, hi, I'm Rob. Then you present a token, which is your basically driver's license, for example. And this token contains claims, like properties. And so you would do claims-based authentication, authorization, and the bouncer would let you in, and you would get access to a resource, which would be a beer service. So claims-based authentication is interesting. There are a few definitions. The best one is from a dude called Steve on Stack Overflow, who says it's about defining who you trust, and only ever trusting the information that this service identity provides. So how does it look in practice? You would usually have someone that you trust, which would be the government, for example. Government has a token service, which would be like the licensing department, which issues driver's license, passports, etc. And they would issue a token, like a driver's license. This token has claims, like properties like name, address, maybe age. And you would usually have some kind of verification, like, has this token really been issued by this identity provider that I trust? And in case of driver's license, this is a holographic token. In IT, this is usually a security token, like a RSA-based signature. And the terminology is very interesting, because there are a lot of standards, and they all call things differently. So we would have the user, like basically the person who we care about. We have an identity provider, which provides us with the identity so that we can really know who is this person, can I trust information. And then there's things that rely on the identity provider to provide correct information. So this is the relying party. This would, for example, be our API service. But it's not that easy. There are a lot of acronyms for these things. So The user is also called the subject, like in scientific research, but also the resource owner. Because like if you create a document, it is your document, your resource, and you own the resource. So when you walk across things like resource owner credentials flow, it's a user. Also, the relying party is usually also called a client, especially when you're doing OAuth. So client means really our application. So if you have client credentials or something, it's a secret of your application. And also there are lots of acronyms for the identity provider. I think the most used is probably the issuing authority, but also authorization server would be widely used. So watch out for these acronyms. So I've mentioned tokens before, so just a quick comparison, what kind of things we have to perform authorization and authentication. So what was traditionally used was passwords, and we would provide the password to the relying party, and the relying party would then know our password, but also use it to access the identity provider and check the password, which is not that secure, because this is a secret, and maybe I don't want to give the secret to some servers that I don't really fully trust, like any Facebook game, maybe not. But then for tokens, there are two types of tokens. There are reference tokens and there are self-contained tokens. So the self-contained tokens would contain all the information that I need to know in the token. And the reference token is basically just a random value, or not random value, that doesn't have any intrinsic meaning, but I need to check what the identity provider tells me for the token. So if I'd have a reference token, I wouldn't log in via the relying party. I would log into the identity provider like Facebook or Azure AD. This identity provider would then provide me with a reference token. I can then send the reference token to the thing that I'm authenticating with. And so this service doesn't know my password. It gets a token, doesn't know what the token means. So it also checks the token against the identity provider. And then our identity provider can send back information about this user, like the identity, all the claims, and also maybe some access tokens that I can use to maybe access Facebook APIs. So, but this involves a lot of communication, so we can use self-contained tokens to simplify this a bit. So I would still log in with my identity provider, then I would get back a self-contained token. But this token already contains everything about my identity, all the claims, all the things that I later need. So I can just provide the token to my self-contained token to my API or relying party, and it would just validate the things because there's a cryptographic signature involved. It also already has established a trust relationship with the identity provider, so it knows all the certificates. So it doesn't need to make a lot of network calls. Like every time I make an API call, it would just check the token that I send with the API call. If it's valid, it's okay. And it wouldn't need to do a lot of network calls. So this enables also some interesting scenarios because usually we don't log in with just username and passwords anymore. We also use authentication apps, mobile phone validation tokens, so basically multi-factor authentication. And implementing that correctly is quite hard. So we shouldn't do it ourselves, right? So when we use external identities like Azure AD, we would just enable two-factor authentication in Azure AD, and all of our applications are a bit more secure. So that's really the benefit of using externalized identity. So let's talk a bit about the standards involved. So about these tokens, especially the self-contained tokens, there are a lot of formats. I'm just going to cover two of them, SAML and JWT. First of all, SAML, which is the OASIS Security Assertion Markup Language, blah, 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 which is basically XML. And it's very concise. And imagine sending that with every request. But you can, if you look really close, you'll see some cryptographic signatures in there, a lot of XML code, tokens, whatever, but it contains everything about the identity. and everything you need to know to do authentication. And it's okay, but it could be a bit easier, especially since SAML has a lot of extensions. It's pretty hard to implement correctly, especially when extensions are involved. But another token format that's now more popular is JSON web tokens. So we use JSON, which is one better than XML. Then there is a discussion if YAML is better than JSON, but let's not talk about that. So much easier, right? Much better than XML. Okay. The trick is this is actually base 64 encoded, so there are 3 dots in there, and the first part is a header, which basically tells, okay, this is the format, this is the signature. So there's a header, there is a body, and there is a cryptographic signature, which is basically a hash of the header and the payload. And if we just base 64 decode, this would look like this. So there is a JSON object that describes the token itself. It tells me it's a joint token. There is an RSA 256 cryptographic algorithm. It references the key that is being used. And then there is the token itself, like all the things that I need to know. So what's in there? So the first thing is the audience. Basically, what is this token about? And like who should use it? So for example, if we have our custom application, the token would be issued for that application because this would be the audience. And the token also contains who issued the token. Like, is it Facebook? Is it Azure AD? Is it something else? And there's things like issued at, expiration times. And then there are a few other claims. The interesting one is there are public claims and there are private claims. So basically there is a specification that lists a few known tokens, but you can still use extension or define your own tokens, own claims. So you have like email address, authentication time, but maybe you will also have some version or an app ID, or maybe Azure AD has some custom claims that you can define. So that's pretty good to use, especially if you have a custom attributes, for example, in your Active Directory, if you have role names or specific company-specific information about users, this would also go into a claim, right? So now that we know about tokens, how do we get this token? So we would use authentication protocols to get these tokens, and there's actually a lot of them, and there's a bit of history involved. So there's of course this line that is SAML. Then I don't know if you ever used WS Federation. So there's like the WS star. If you've done XML web services in the past, this is a pain in the ass. You don't want to do this anymore. And basically, the latest one is OpenID Connect, which is actually an extension of OAuth 2. And OpenID Connect, I think, is the one that you should use, because it makes OAuth 2 a bit safer to use, because there are ways that you could implement OAuth 2 that will actually make your application vulnerable to a few attacks. So if you're implementing a new app, make sure you can use OpenID Connect, right? But most of these protocols have a few things in common, right? So there is this basic concept, this basic flow, that whenever I want to log in, I go to the application tells me, oh, I should log in, right? So it will generate a redirect and send the user to the identity provider, right, through a redirect. And once the user is logged in and it authenticates, there will be another redirect back to the relying party. If you're already signed in, for example, in Azure AD or Facebook, maybe this would just be some browser URLs changing, and you would just wait a second and it automatically works. Maybe we would have to log in, but maybe you would also need to grant the application access, like consent, right? And then the relying party processes the response and does something with it, right? And this also works in, for example, SAML. Actually, in SAML, SAML is both a token format, but there's also an authentication protocol associated with SAML, right? You send the request, you actually send this XML, base64 encoded in the GET request, so maybe it works. But you can use post as well. You send some state, you send some information, and you get a response back, right? In OAuth 2, you do something similar, but with a lot less stuff. You would also send a post request, but there are things there that you would need to do for OAuth 2. And basically, OpenID Connect uses OAuth 2 as a protocol. It just specifies what features you can and should use, and how you negotiate the things that you use. So when you're authenticating with OAuth 2, you tell the endpoint, what do I actually want? What kind of tokens do I want? In this case, it's code. I'll explain a few variants later on. And you provide information about the relying party, which would be the client ID. And you would provide the redirect URI that the user would be sent back after authentication. Right, so OpenID Connect helps to simplify all of these things. The idea is that for OAuth 2, sadly, you have for like Facebook, Twitter, and others, you would need slightly different implementation, slightly different user code. But for OpenID Connect, it would be the same code. And OpenID Connect can be used for authentication and authorization, and it mostly uses JWT as a token format. But you can also use reference tokens for a few token types. And there are also extensions for like discovering services, or maybe dynamic client registration, which is interesting. And the idea is that the list of implementers grows from basically day to day. So there's a lot of libraries involved. There is a certification project that you would need to go through. But basically all the big providers like Authz, Azure AD provide these kinds of things. And even if you have an on-premise like Windows server, you would use Active Directory Federation services, which I think since version 2016 also supports OpenID Connect. So let's have a bit of more detailed look into OpenID Connect. So there are a few fundamental concepts of OpenID Connect that I would like to talk about. It's like relying parties, the metadata involved, what are scopes, and then basically what types of tokens there are, right? So for our clients or relying parties, we would need to register this client in advance. So if you have ever developed with like Facebook or Azure AD, you would need to register the client, and you would get a client ID and a client secret. Usually, maybe you the specification says that if you don't have a secret, the secret is actually empty, and you have a secret which is empty and confusing. But the idea is that the relying party will always construct a request to the identity provider, and you would always identify it with the client ID. But there is a bit of a distinction. There are public clients and confidential clients. The differentiation is confidential clients can actually keep a secret, right? So if I provide, if a client has a client secret, and I rely on that secret to be kept secret, I can maybe issue more rights or more like tokens that would require the relying party to keep secrets. But maybe there are public clients which cannot keep secrets, which would be like single-page application websites or even desktop applications, because the user or maybe a malicious party could read the tokens or the values from memory or from disk and access them. So confidential clients are usually what you run on a server, right? So how do I set up OpenID Connect? The idea is OpenID Connect has a configuration format, so, and a well-known URL. So if I have a URL to like Azure AD, the library would call a specific URL, .well-known/OpenID configuration, and get all the configuration that it needs, like what certificates are involved, what token types are supported, which maybe claims extensions are in use, and what are like all the URLs that he needs to send people to. So it basically don't have to do a lot of things. So which is why most of the libraries that you can use to use OpenID Connect are usually just a few lines. You configure which service you want to use, and it will automatically fetch all the metadata that it needs to use that service. And this metadata also has a specified refresh interval, so you would always be up to date. Then there are scopes. When you send the user to this identity provider, you would usually ask for specific information or specific access types. Like, for example, if you log in with Facebook, it would tell you, oh, this application wants to read your name, your email address, your friend list, post your feed, post whatever. And the idea is that some of these are actually optional, and this would be consent. Like, maybe you would ask the user for consent to tweet as this user. So you can tailor the authentication or the authorization that maybe you want to do with the tokens that you get back, right? And there are a few standard scopes. So whenever you use OpenID Connect, you have to require the OpenID scope. And then there are a few standard scopes like access and profile, email address, phone. And if you want to stay connected for a longer time, like you have a Spotify service that will automatically be connected to Facebook for like forever, there's also offline access, which would give you refresh tokens to be able to keep this grant, this authorization alive and get new tokens when the old ones expire. These are things that you would only do with confidential clients. So what are the tokens that I can actually request? So there is an ID token. The ID token is basically a driver's license that is usually used for a few minutes and usually only one time. And it contains all information about the user, maybe some profile, and you would just read it once. But if you want to access a service, which would either be if you write a custom API and you want to authenticate users via Azure AD, you would maybe check an access token from an application. Or if you're like Twitter, you want to have an access token with which you can tweet as this user, right? And then there's also refresh tokens. Like if you supply this offline access scope, you would also get a refresh token. And if your access token expires, you would use the refresh token to get a new access token. And this way you can keep the application alive. But then there is also a code token. The code is just a reference token. And the idea is that you can exchange the code for other tokens. I'll show you when this will be used later on, right? And the things you would get in OpenID Connect is a draw token, usually, like ID token, with a few defined claims, right? So there's always the subject, so the actual user that I care about, issuer, the audience, basically, is it Twitter, is it maybe service 1, API service 2, whatever, issued at, expired, and maybe also some optional claims like which authentication method was used to authenticate the user, some number that is used only once if you want to prevent replay attacks, and yeah, auth time, and something else. Like you can maybe extend this if you use a library, you would maybe extend this. So, what do I actually use to talk to this identity provider, right? So we've talked about the things that the concepts that make up the things that I use as a application, but how do I actually talk to this identity provider? So the identity provider has 3 endpoints that are defined in OpenID Connect: the authorization endpoint, token endpoint, and the user endpoint. So the authorization endpoint is where you would send a user, right? But why would you call it authorization if you want to do authentication? Well, actually, authentication is what the user does, but the user basically authorizes your application to use his identity for your authentication. So, auth star. And you would use the token endpoint to get tokens. Like if you have a refresh token, you would go to the token endpoint to get new access tokens. And if you want to get some information about the user, because maybe a user profile in Active Directory can be huge, and you don't want to include that in the token, maybe you can go to the user info endpoint and get all this information. But also if you log in once and you get one ID token, maybe 3 weeks in something changes in the profile and you can get the new profile from the user info endpoint, which is useful if you want to stay connected using refreshes, right? So authorization endpoint is where you would send a user to. You would specify which response do I want, which tokens do I want, and I would get a redirect, and afterwards the client would redirect back. And the idea is that the authorization endpoint can do anything that it wants to actually authenticate the user. So maybe this is just a quick redirect because single sign-on works. Maybe this is a Facebook login. Maybe the authorization endpoint will also redirect the user to somewhere else. Like maybe I can log into Stack Overflow via Twitter. So this can be a few hops back and forth. And this is also usually the point where you could configure multi-factor authentication. So if you're using like Azure AD, this also has some AI logic to maybe require the password to be entered another time if the user has some suspicious activity. Maybe it would redirect back. Maybe it would send a SMS because the user hasn't used SMS for 2 years, and you don't want to care about that. This is where you actually benefit from security experts to implement the things perfectly. Right, so token endpoint. Again, I told you I can get tokens from that. So the interesting thing is this. If I go to the authorization endpoint and just request like a code, I could go to the token endpoint and exchange the code for like an ID token, access token, and refresh token. Or if I have a refresh token, I could exchange the refresh token for an access token. So basically, I need to provide some sort of credential or authorization token and exchange it for like access tokens and ID tokens. So more examples later. Yeah, let's skip that. And the user info endpoint is basically where I can get up-to-date information about the user. Like maybe this is newer if I have an old ID token, or maybe this will get me more than I would actually get in that token. So there's a lot of things that are standard, but usually there's a lot of extensions involved, especially in Azure AD. So what can I actually do? Like I send the user somewhere, he comes back with some information, but the idea is there are a few flows that you need to choose, and this is actually the hardest part about OpenID Connect, because you need to choose the right flow for the use case that you have in your application, right? And there are interactive flows and there are non-interactive flows. So non-interactive flows are a bit special, so we'll deal with them later. The interesting thing are the interactive flow, where the actual user has to do something, like click in the browser, be redirected somewhere and redirected back, basically where I give control over to let the user do something. And there is an authorization code flow, implicit flow, and a hybrid flow. So basically you need to choose on the type of application you want. Like if you have a single page application, you maybe would do things a bit differently than if you just have a server-side application. And let's talk about the flows in a bit more detail and have a summary later. So authorization code flow is something where you actually have a confidential client. So like a server application. And the way this works is I redirect the user to the authorization endpoint of the identity provider, and I ask the identity provider, please give me a code token, right? Then the authorization endpoint gives back this code token, this authorization code, but the thing is, the user can't actually do anything with that code, right? Because he sends the code to the relying party, and the relying party can use its client credentials that the user doesn't know. This is the client secret that you will get like from Facebook or Twitter. And only with this secret, you can exchange this code for tokens. And this is also where you would get a refresh token to be able to have a longer connection. If you have maybe a public party that cannot keep secrets, you wouldn't do that. But there is a flow for that, because you would redirect the user again to the identity provider, and you would get back directly the ID token and the access token, but you cannot get a refresh token. So maybe you would be logged in for an hour. So maybe this is a single page application that can hit the Twitter API or save tokens locally, but everyone could like steal the client ID and maybe client secret of this application. So you don't want to be able to stay connected for longer times and need to re-authenticate the user. So if you have an application that basically logs you out a lot of times or redirects somewhere and redirects back before you actually see the thing that you clicked on. This is maybe using implicit flow. And this is very good to use for single page applications, right? But also you can use this token, ID token and access token, and maybe send it somewhere else. Like the party could be a desktop application, or you could use this single page application to use this token that you get like from Azure AD to also authenticate against an API that you call. So this is very useful, but there's also a hybrid because you can ask for a code and ID tokens and refresh tokens. And the way this works is you would get a code that maybe the single page application can't exchange for other tokens, but the single page application could get like the ID token and actually know what his name is and could display information, but send the code off to another part of the application. So you could have like a thing in the browser that just gets ID token and access token, and you would send the code to your backend, which could then exchange it for a refresh token and stay connected for longer time. So this is where you would choose hybrid. And there's a long table, which gives you a bit of an overview of what things to consider when choosing a flow. So do you want to reveal tokens to the user agent or not? Like, are you afraid that someone will steal tokens from your Android application or your single page application? Do you want to stay connected for a longer time? And also, do you want to have less or more round trips in your authentication flow? And so the way you do this is you specify the response type, where you ask what do I actually want from the identity provider, and you would maybe just get an ID token. Maybe this is, for example, used as a default if you use the OpenID Connect integration for ASP.NET Core, because maybe you're using ASP.NET Core Identity, which has its own user management, and you would just use one single ID token to just identify the user once. And there would be a replay cache involved, and you could only use this token once, and that's it. But maybe you want to stay connected for a longer time, which means you need to use the authorization code flow or the hybrid flow. So maybe let that sink in for a minute at home and revisit when you actually have to implement something. So I mentioned there are a few special flows as well, and there's also non-interactive flows where the user doesn't do anything. And there are two use cases that this actually can be done. But this can only be done with confidential clients because we think that this client can actually keep a secret. So one would be the resource owner credential flow. So resource owner is the actual user, and its credentials would be like passwords. And this is also called the password flow. But previously we said we don't want to use passwords, so why is there now a flow for using passwords? So this is what you actually would do for first-party application. Like, if you are the Twitter application on the phone, you need to log in to Twitter with username and password. You have to do it somehow. And if you already have an OpenID Connect infrastructure, you can also do this via OpenID Connect. So please only do it for first-party applications. You could also do this when you're writing a single-page application. There's a login form, and you want to log into your own service. You could do this in there as well. But please don't do this for third-party apps. So, like if you authenticate against like Azure AD, Facebook, Twitter, whatever, they won't let you use the password flow unless you can extract a secret from the application. But let's not talk about that. And there's also, you would send the credentials. The relying party would know the credentials, and you get the tokens back, right? But there's also a client credentials flow. Again, client in this case is the application, like the relying party. And this is very useful where you don't want to describe the identity of an actual user, but the identity of a service. So if you have like multiple worker services, API services, maybe you have an API service that needs to authenticate against a database or a different service, you could use the client credentials flow and get actually a token that identifies you as a service if you have service-to-service communication. So That's a lot. I'll show you a demo, quick demo. There's no coding involved, just some show and tell, because this actually works. So this is a ASP.NET Core application. It hosts an Angular application. And what I did here, no?
No.
Then I probably,
Okay.
yeah.
Better.
Oh, okay. So I'm sorry, this is still an ASP.NET Core 2.2, I think, application, but it works. And the thing, I would set up OpenID Connect in my API, like if I have an API that needs to authenticate against something. What would I actually use? I would tell this application that I want to use JWT as tokens to validate. And I would tell it, hey, please make sure that the tokens come from this identity provider. There's a specific audience involved. So in this case, this is an example for a university, the Übung 5. So there's an API. This is the API service for an exercise. And I only accept tokens that were issued for this API service, for this audience. And then I would have controllers that would save to-do items in the database. And then I would authorize, so I would need authorization. So there needs to be an access token for my service in the HTTP request to the backend service. So how could I do this in the front end? So the idea is that all the configuration that the front end needs is it needs to know about the identity provider. So in this case, this is a sample identity provider that are already pre-configured, which should work. Where I can log into. This is basically an instance of identity server. I can share the code later, which is configured to know about the types of clients and the audiences, etc. I would request the OpenID scope, access to profile, and also I would like to access my API service that is configured in identity service. So I have a custom scope that tells that basically is also included in the token that I get. So my API service can check if the user actually provided consent to use this application. And the way this can be done, for example, in Angular, is by using the Angular OAuth 2 OpenID Connect package, which is built by Manfred, who also lives in Austria. And what he would do is he would construct a callback URI, which would also be handled again by the single page application. In this case, just the custom current URI. And I would configure an OAuth service. I just need to pass it this information. I tell it that there are JSON web keys involved for the signature for the JWT tokens. I would also tell it, hey, you can use local storage to store things. And then there is this magic method, load discovery document and try login. And whatever OpenID Connect library you use, it would automatically configure itself based on this URL. It would fetch this well-known OpenID Connect configuration document, fetch all the keys, and know which APIs it has to talk to. And we can ask it to log in. And I'll just also, spoiler alert, there is a login button on the side. And what it does is it calls init implicit flow. So the application would request a token, would be redirected back, and then it would have a token. And the way this can be used, for example, in Angular, is I would use an HTTP interceptor. So whenever I use the HTTP APIs in Angular, I can register an interceptor, which is basically a pipeline handling, where I can inject myself into every HTTP call. And if I'm logged in, if I have a valid access token, I would set the authorization header to bearer and my access token. So let's have a look if this actually works. Maybe. Right. So there is a to-do list. There is an API. I can query all the to-do items, but I can't do anything. Like I can't remove. If I inspect the network calls here, right, 401 unauthorized. But if I log in, I initiate the implicit flow. I get redirected to my identity provider, and you can see there is a return URL in there. My response type is ID token, so I want to get the profile, and token, the access token, but there is no offline access, so this is just the implicit flow. And the client ID is actually public. Everyone that browses my site can read this, so it's not confidential because everyone would know the secret. But I can log in, so I can log in like as a Alice, pass 123 $, and then log in, right? And then, because I requested the scope, this access to this API, I would then need to provide consent for this API service to use my user data. So, because I requested profile as a scope, it asks me, do I want to give access to the user profile? And do I want to give access to this API? So in this case, this would be optional. Maybe not configure your API services as optional, but yes, allow. And now I should be redirected back. And for a second there in the URL, you would have read a URL fragment that contained the tokens, but the library already extracted the tokens, and I'm logged in. And because there was an ID token involved, the library reads that information from the token, and I can start, if I hadn't misconfigured CSS, add items and remove some, right? But this is only half the fun, because maybe try this as another user. Because I mentioned the authorization endpoint could do anything. So maybe if I log in, maybe I want to use external login on this identity provider as well. So maybe I'll log in via Twitter to my identity provider, which will now use OAuth via Twitter. Come back from Twitter. I already granted access on Twitter. And now I can go back to my single page application. Right. And I'm logged in as Dasmolian. And things work. Right. So, questions? Yes?
You mentioned the phrase reference tokens.
Yeah.
Can you explain what a reference
So,
token
Please repeat the question on stream.
thank you. I would have forgotten it. So the question was, so I've mentioned reference tokens a couple of times and never showed any. What's the difference? So the difference between reference tokens and self-contained tokens would be, for example, JWT tokens. These JSON web tokens are self-contained. They contain all these informations, like the issuer, all these claims, and I can basically decode the JWT token and read all the things in there. The difference to a reference token is the reference token could be just like maybe a UUID, a GUID in .NET, and maybe I would need to check that with the identity provider, like, hey Azure, what is the user or the identity behind this number of characters that I don't understand, right? The big difference that this makes in practice is self-contained tokens actually can't really be invalidated, right? They have a signature, they have an expiration date, and that's it. So if I maybe log out in Twitter, and I'm maybe not Twitter checking this access token, I wouldn't know that the user has logged out. So during security audits, this may come up as an issue. There are a few experimental specifications that deal with revocation for a bit. But for example, reference token, if for every API call that I make to my service, I would need to check what is meant by that number of characters that I don't understand. The service could sometimes just stop giving me nuts and tell me, yeah, this thing is not valid anymore because the user has logged out or revoked access or something like that. So if I have an access token that's valid for an hour, it's valid for an hour. And maybe if I log out in another service, I would have to keep a cache of things that I no longer want to accept, which is maybe a bit more complicated. But the reference token, I can invalidate it every time. But I need to make a lot more network calls to check if this token is actually still valid and which user this token refers to. So it's a design question. Other questions?
I got a remote question.
Oh, remote questions.
Yeah.
Should.
Is the source of the example somewhere available?
Yeah, it will be available. I think I'll post a link on Meetup later. I'll upload it to GitHub. If you're studying at Technikum Wien, you should have access to it on Moodle. But I will make this available later, of course. Yeah.
You mentioned two special flows, and the second one was client credential flow, I think.
Yeah. So
is it then on behalf of the original user, or how is the user involved in his backend calls?
So the question was, I mentioned special flows that are non-interactive, and there is one that's called the client credential flow. How is the user involved in this client credential flow? Not at all. So this is not an on behalf of, this is just, I am API service, I want to access the database. Can I do that? Maybe yes, maybe no. So if you have service-to-service communication, this would be a way to use the client credentials. If you have a confidential relying party, a confidential client, it would be able to keep the secret and use the secret to get a token that has the identity of basically my application. Okay.
Thanks.
If there aren't any more questions, we should do a 10 to 15 minutes break. There are drinks in the fridge, also beer, some snacks to eat. There will be more to eat later, and see you again in 10 to 15 minutes. Thank you.